Bismillahirrahmanirrahim. Assalamualaikum and a very good day to everybody. Okay, so for today's class, we are going to proceed with our topic Indices, Surds and Logarithms under the subtopic Change of Base in Logarithm. Okay, let's begin. Okay, our objective for today's lesson are, at the end of the class, you should be able to determine the logarithm of a number and prove the relationship of log b base a is equals to log b base c over log a base c. And then you should also be able to solve problems involving law of logarithms. Okay, so first of all, let's look at the derivation of change of base in logarithms formula. Okay, if a, b and c are positive numbers, then a is not equals to 1 and c not equals to 1, then it is said that the formula for change of base in logarithm b will be log b base a equals to log b base c over log a base c. Okay, suppose that log b base a equals to x, so b is equals to ax. So how come we have this term b is equals to ax? So generally log y base a is equals to x. So this is our this is our log form. Okay, and then we have our index form, which is from here it can be y is equals to a to the power of x. So this is our index form. Okay, so this is our index form. So suppose that log b base a equals to x, and then becoming b equals to a to the power of x. So what we do here is we change from log form into index form. Okay, so next, log a to the power of x base c is equals to log b base c. So what happened here is we use the same logarithmic base on both sides. So from b equals to ax, okay, from here we add log for both sides, in which the log that we use, the base is c. Okay, the base is c. Okay, next. Okay, so as you can see, this part a to the power of x. Okay, a to the power of x. So the next step, x log a base c is equals to log b base c. So what happened here, it applies the power law of logarithm. So the power law of logarithm states that, so if we have log y base a to the power of n, so it will become n log y base a. Okay, so this is what happened here. Okay, next. So from here we can say that, oh, x is equals to log b base c over log c base a. Okay, since log b base a equals to x, thus log b base a equals to log b base c over log a base c. Okay, wait why? Okay, so since log b base a equals to x, thus log b base a is equals to log b base c over log a base c. So we have proved the formula. Okay, next. Okay, if b equals to c, then log b base a is equals to log b base b over log a base b, which is equals to 1 over log b base a. So before we said that, oh, log b base a is equals to log b base c over log a base c. So in this case, it states that if b equals to c, so we substitute the c with b. Therefore, we have 1 over log a base b. Okay, so any logarithmic base can be written and evaluated with base 10 or base e. Okay, logarithmic base 10 or base e, in which logarithm with base e are known as natural logarithms. Okay, natural logarithms, and are written as log base e, or we can say it as ln. So this is ln. So ln stands for ln. Okay, so base e is often used in mathematics, science and technology. Okay, next. Okay, in A means log A base e with e as an exponent base. The number is a non-recurring decimal with which is 2.7182 ... Okay, so observe the following. So log 10 is said to be equals to 1 because of what? Because log 10 base 10 equals to 1. So before, we know that when we have log A, this base is the same. Okay, log A base A will have 1. So log 100 base 100, 1. Log 2 base 2, 1. Okay, so the same goes to ln E. Okay, ln E is actually log E base E. So it will become the same. Okay, so how about ln E to the power of x equals to x? So ln E to the power of x equals to x. So we said that, oh, this is power law. So x ln E will be x. Okay, ln E is equals to 1. Okay, here we said that, oh, ln E is equals to 1. So we will have x. Okay. Okay, so next, how about E ln x? Okay, how about E ln x? Okay, for this part, we need to let, we need to let y equals to E ln x. Okay, so since since y equals to E ln x, so we let ln y equals to ln E ln x. Okay, both side with we make both side log base E, okay, which is ln. Okay, so since this is power, so we said that, oh, ln y is equals to ln x times ln E, in which ln E is 1. Okay, so we have ln y is equals to ln x. So previously, you have known that when we have log y equals to log x, we said that, oh, y is equals to x. The same goes to ln. So we said that, oh, y is equals to x. Okay, again, what is our x? What is our y? So since our y is E ln x, so e to the power of ln x, therefore y equals to x equals to e to the power of ln x equals to x. So the same goes to 10 to the power of log x equals to x. So the same method, you try to prove 10 to the power of log x will become x. Okay, next. Let's look at example 1. Okay, determine the following values by changing their bases to 10. Changing their bases to base 10. Okay, let's look at A log 22 base 3. Okay, so the initial base is 3. So we know that the question asks us to change it into log base 10. Okay, so we also know that the formula for change of base in log is log b base a is equals to log B base C over log A base C. Okay, so just we know that A here is 3, B here is 22. So what is C? C of course is the base 10 that we need it. Okay, so we just substitute the values. Okay, so we know that log 22 base 3 is actually equals to log 22 base 10 over log 3 base 10, and then you can find the values by using calculator. So we have log 22 base 3 is actually 2.8137. Okay, simple, right? The same goes to B, log 1.32 base 6. Okay, so we can see that our A is 6, our B is 1.32, and again C is the base that we want, which is base 10. So we just substitute the values in the formula, and then we can say that log 1.32 base 6 is actually equals to 0.155. Okay, so this is simple question. You just need to use the formula. Okay, this is direct question. Okay, next let's look at example 2. Convert each of the following to natural logarithms and evaluate them. Okay, natural log. So we know that natural log is log base E. Okay, so A, log 2 to 5 base 7. So we know that logarithm with base E is known as natural logarithms, and we also know that the formula in change of base in logarithm is log B base A equals to log B base C over log A base C. So our A is 7 for A and B is 2 to 5. So C, again, C must be log base E. Okay, so substitute the values. Okay, so we have log 2 to 5 base 7 is equal to log 2 to 5 base E over log 7 base E. But how can we find base E? Okay, how can we find base E? Because previously log base 10, we can just press in our calculator, just press log and then the value log 2, let's say, and then you get the answer. How about base E? Okay, when we talk about base E, okay, base E, you press ln. Okay, at your calculator we have a button ln, so press ln. So if you want to find log 2 to 5 base E, so press ln and 2 to 5 and then equal. So you will have the value of log 2 to 5 base E is 5.4161. The same goes to log 7 base E. Press ln and then 7 and then equal. So we will have 1.9459. Okay. I would like to remind you, this is working, right? So when working, of course, at least 4 decimal places. Okay. Okay, next. So our answer for log 2 to 5 base 7 is 2.7833. Okay, 2.7833. Okay, let's look at B. Log 3 to 4 base 9. Okay, and then substitute the values in the formula. So we have log 3 to 4 base 9 equals to log 3 to 4 base E over log 9 base E, and then press in calculator, okay, by using ln. So we will have the value of log 3 to 4 base 9 is actually 2.6309. Okay, simple, right? Okay, next. Example 3. Given log 2 base 3 equals to t, express each of the following in terms of t. So we don't need to solve, but we need to express in terms of t. Okay, so we have A log 9 base 2 and B log 8 base 9. So how can we express it in terms of t? Of course, in order for you to express in terms of t, you need to have log 2 base 3 term. Okay, you need to have that thing, log 2 base 3. So we can see that from our base is 2. However, in order for us to have t, we need to change it in base 3. So what are you going to do? Of course, you are going to use the change of base formula. Okay, change of base formula. So a here is 2, b is 9, and then of course our c would be 3. Okay, because the question gives us log base 3. Okay, and then what can we do? We need to relate 9 with 3 or 2. Okay, so how can we find 9? Of course, if we multiply 9 times 1 or 3 times 3. So we can say that, first of all, we change the base first. And then we can say that, 9 comes from 3 times 3. So log 3 times 3 base 3 over log 2 base 3. So 3 times 3, you can simplify it as 3 squared. Okay, so we have log 3 squared base 3. So as you can see here, this is power or index, right? So we have our power law, in which if we have log x to the power of n base a, then it will become n log x base a. So what happened next is, okay, the power is in front of the log. So 2 times log 3 base 3 over log 2 base 3. So again, we can see, this is another log properties, in which log a base a is equals to 1. So we can say that log 3 base 3 is equals to 1. And what is log 2 base 3? Log 2 base 3 is t. Okay, log 2 base 3 is t. So 2 times 1 over t. So our answer would be 2 over t. Okay, remember, you need to relate the number with the info given. Okay, let's look at B. Okay, B, log 8 base 9. Again, we need to change base 9 into base 3. Okay, so by using the formula, we said that, log 8 base 9 is equal to log 8 base 3 over log 9 base 3. And then we need to think, how can we relate 8 with 2 and 3? Okay, how can we get 8? 1 times 8. How can we get 8? 2 times 4. But we cannot relate it. 2, of course, we have 2. But 4 is not in the question. The question gives us 2 and 3. So what are the things? Okay, what are the alternative methods can we get 8? So instead of 2 times 4, we can say that, 8, we can say that, this is 2 times 4. Instead of 2 times 4, we can say that, 8 can be found by multiplying 2 times 2 times 2, right? 2 times 2 times 2, in which we can simplify 2 times 2 times 2, 2 to the power of 3. So we can relate 8 with 2 and 3 now. Okay, again, how can we find 9? Of course, 9 can be found by 3 times 3. Again, 3 squared. Okay, so let's look next step. So the next step, we can say, log 8 base 3 is actually log 2 to the power of 3 base 3. And log 9 base 3 is actually log 3 squared base 3. So here we can see that, this is properties involving power. Okay, power law. So when power law, of course, we said that the index will be in front of the log. So we have 3 log 2 base 3 over 2 log 3 base 3. Okay, so what is log 3 base 2? Log 3 base 2 is actually equals to log 3 base 2 pula. Log 2 base 3. So log 2 base 3 is actually equals to t. And what is log 3 base 3? Log 3 base 3 is equals to 1. So our final answer will be 3t over 2. Okay. Okay. Simple, okay. Okay. We move on to example 4. Okay. If log m base 2 equals to a and log n base 2 equals to b, express each log, express log m squared and cube base 4 in terms of a and b. So express that log in terms of a and b. Again, if we want to express it in a and b, of course, if we want to express it in a, we need to have log m base 2. If b, we need to have log n base 2. So our question is log m squared and cube base 4. Okay, this is base 4. Meanwhile, the question gives us base 2. So of course, in your mind, you need to know, we need to use the change of base formula. Again, okay. As you can see here, this is actually equals to log m squared times n cubed, right? Base 4. So we can say, this is another law. Okay, another law. Which if we have multiplication operation, so actually the log is addition. Okay, so we separate it as addition. So log m squared n cubed base 4 is actually equal to log m squared base 4 plus log n cubed base 4. Okay, this is the rule. Okay, this is the rule. And then we said that, we want to have our a terms and b terms. So in order for us to have a and b, we need to convert the log base 4 into base 2. So we use the formula of change of base. Okay, so by using the formula, we can say that log m squared base 4 is actually equals to log m squared base 2 over log 4 base 2. The same goes to log n cubed base 4 is actually log n cubed base 2 over log 4 base 2. Okay, now we can see that is 4. So the question gives us 2. Okay, so how can we relate 4 with 2? So of course 4 can be found by 2 times 2, or we can say that 2 squared. Okay, so from here we can say that this is actually log m squared base 2 over log 2 squared base 2 plus log n cubed base 2 over log 2 squared base 2. Okay, so again we need to involve the power law. Okay, the power law, and then we have 2 log m base 2 over 2 log 2 base 2 plus 3 log n base 2 over 2 log 2 base 2. So what is log m base 2? Log m base 2 is actually equals to a. What is log n base 2? Log n base 2 is actually b. And then we can see, this is log 2 base 2. So log 2 base 2 is equals to 1. So now we need to substitute the value of log n base 2 and log n base 2. So we will have 2a plus 3b over 2. So that is our final answer. Okay, easy, right? Okay, chill. Okay, let's move on. Let's look at solving problems involving the law of logarithm. Okay, example 5. Solve the following questions. Okay, A. 4 to the power of 2x minus 1 equals to 7 to the power of x. Okay, this is index form. Okay, this is index form. So as you can see, the left hand side is, the base is 4, and the right hand side, the base is 7. So 4 and 7, we cannot have the common base. But if 7 replaced by 2, we can change 4 into base 2. So we can say, oh, 4 and 2 have the same base. The same goes to 3 and 9. The same goes to 2 and 8. But now 4 and 7, we cannot have the same base. So when we see this type of question in which we cannot have the same base between left hand side and right hand side, so in order for us to solve the question, we need to use log. Okay, we need to use log when the bases cannot have the same base, if the question given is in index form. Okay, so the next step, we add log at both sides. Okay, log base 10. Okay, we put log base 10. So log both sides with log base 10. So we will have log 4 to the power of 2x minus 1 base 10 is equals to log 7 to the power of x base 10. Again, we can see, oh, this is power law. Okay, this is power law. So we apply the power law. So we have 2x minus 1 times log 4. Okay, times log 4. Okay, I'll make a bracket here. And x times log 7. Okay, so the next thing, we find the value of log 4 base 10 first. And then we find the value of log 7 base 10 first. And then what are we going to do is we expand. Okay, we expand. So we will have 1.2042x minus 0.6021 is equals to 0.8451x. So the rest of it, you just need to solve the linear equation. And the answer for x is actually x equals to 1.6767. Okay, remember, if we have index form equation and the base cannot have the same base, in solving that type of question, we need to log both sides. You need to solve it by using log. Okay. Okay, let's look at B. 5 to the power of 2x minus 1 and 79 to the power of x minus 1. Again, 5 and 79 cannot have the same base. So, solving it must use log. So, what we do here is we log both sides with log base 10. So, we will have log 5 to the power of 2x minus 1 base 10 equals to log 79 to the power of x minus 1 base 10. Okay, so again we see, oh, this is power. So, we need to apply the power law. Okay, we need to apply the power law. The next step, find the value of log 5 and log 79. And then the same thing, expand. Okay, when we expand, we have 1.398x minus 0.699 equal to 1.8976x minus 1.8976. So we have linear equation here. And then you solve linear equation, we will have our value of x is 2.3991. Okay, simple. Okay, very simple. Okay, let's look at example 6. Solve the following equations by using natural logarithm. Okay, let's look at A. Ln 5x plus 2 equals to 15. Again, ln represent log base E. Okay, natural log. Okay, ln 5x plus 2 equals to 15. So, the question given is in log form. So, how can we solve the equation? So, when we talk about solving, we need to find the value of x. Okay. So, from ln, we change it into log base E. Log 5x plus 2 base e is equals to 15. Okay, we transform ln into log base e. Okay, so the next step we have e to the power of 15 equals to 5x plus 2. How from this part becoming this part? Okay, again, this is in log form, in which log y base a equals to x. Since we need to find x, okay, so we need to change it into index form, in which y is equals to a to the power of x. Since we need to find this, bukan x we need to find this, okay, since 5x plus 2 is actually y here, right? Okay, since we need to find 5x plus 2, we need to change the log form into the index form. So that is why from here we say, oh, this is a, this is x. So y is equal to a to the power of x. So our y is 5x plus 2. So a to the power of x is e to the power of 15. That is why from this part it changes into this part. Okay, I hope you understand that. Okay, what these steps mean is changing from log form into index form, because we are solving for the value of x there. Okay, next. Here. Okay, next. Okay, use your calculator, find e to the power of 15. Okay, e to the power of 15. So we will have 3269017.372 equals to 5x plus 2. So you solve the linear equation, and then we have our value of x is actually 653,803.07. 653,803.07. Okay, let's look at B. Okay, B, the question gives us in index form 30 e to the power of 2x plus 3 equals to 145. So before, in log form, we change into index form. Of course, here, index form, we need to change into log form. Okay, first of all, e to the power of 2x plus 3 equals to 4.8333. Okay, because 145 divided by 30, we will have 4.8333. So, the next step, the next step, when we have index form, instead of we change it into log form, we have an alternative. We add log for both sides. Okay, so like here, we add ln for both sides. Okay, we transform into ln for both sides. So we have ln e to the power of 2x plus 3 equals to ln 4.8333. Okay, and then this is power rule. So 2x plus 3 times ln e is equals to ln 4.8333. Okay, what is the value of ln e? Ln e is equal to 1. So basically we said that, oh, 2x plus 3 is equals to ln 4.8333 lah. So 2x is equals to ln 4.8333 minus 3. So we have our x is actually equals to negative 0.171222. Okay, 0.71222. Okay, next example, example 7. Okay, this example is from your textbook. Okay, the temperature of a block of steel rises from 30 degrees Celsius to T degrees Celsius when it was heated for X seconds. Given T is equals to the product of 30 times 1.2 to the power of X. Determine A, the temperature of the steel when it is heated for 10.4 seconds. B, the time X in seconds taken to increase the temperature of the block of steel from 30 degrees Celsius to 1500 degrees Celsius. Okay, so first of all, the first step, we need to write all the information given. Okay, so the formula for the temperature is T is equals to 30 times 1.2 to the power of X. And then the temperature rises 30 degrees Celsius to T degree Celsius. So determine T in which T is the temperature, when X is equals to 10.4 seconds. So that is A. Okay. And B, determine X, the time, when the temperature is 1500 degrees Celsius. So that is understanding the problem. And the next step, what you need to do is you plan the strategy. So of course for A, since we are looking for value of T, we need to substitute the value of X in the formula for T. For B, since we are looking for X, so we need to substitute the value of T in the formula of T. Okay, so the next part is we do the calculation. So A tadi we said that, oh, what is T when X equals to 10.4? So we substitute the value of X 10.4. So we know that when 10.4 seconds, the temperature of the steel is 199.8 degree Celsius. When B, what is X when T equals to 1500? Okay, 1500. So again, substitute the value of T. Okay, so we can see that, oh, 50 equals to 1.2 to the power of X. Again, this is index form. So what are we going to do here? We log both sides. So log 50 base 10 will be equals to log 1.2 to the power of X base 10. So this is power law here. Okay, this is power law here. So that is why the next step, log 50 equals to X log 1.2. And then we solve for X. We have X is equals to 21.4567. Okay, so the time taken for the block of steel to reach the temperature 1500 degrees Celsius is actually 21.4567 seconds. So what we do here is we apply all the law of logarithm that we have learned. Okay, so this step is checking your answer. Okay, it's checking your answer. Okay, example 8. The price of a house after n years is given by 260,000 ringgit Malaysia times 9/8 to the power of n. Determine the minimum number of years for the price of the house to exceed 300,000 for the first time. Okay, so we know that this formula is about the price of house after n years. So the question asks, in what year the price of the house will exceed 300,000? So exceed, when we talk about exceed, of course it must be greater than. So we see that, oh, we cannot solve this easily. Okay, so 9/8 to the power of n is greater than 1.1538. Where do we get this value? 300,000 divided by 260,000. So the next step, we need to log both sides with base 10 because this the previous step is in index form. So we add both sides with log base 10. So this apply power law. Okay, log both sides, and then this apply power law. So we have n log 9/8 base 10 greater than log 1.1538 base 10. Okay, here you can see that this part is actually log a y over x. So it involves quotient. So in log, quotient will become minus. Okay, become minus. So we can say, oh, n times log 9 minus log 8 greater than log 1.1538. So you just solve like usual. So we can say that, oh, n is greater than 1.2124. Since we are talking about n is years, so we cannot have decimal value. So n is actually, since n must be greater than 1.2, so the closer one would be n is equals to 2 years. Okay, I hope you can understand. Okay, oops. Okay, test yourself. Okay, so this I give you 2 questions to try, and of course discuss the answer with your teacher. Okay, so for homework, okay, a few I can say quite a few quite a number actually, not quite a few, quite a number but of course you need to do all the questions so that you can have better understandings on the lesson. Okay, before I end up my session, I give you with this word, I end it with this word: mathematics give us hope that every problem has a solution. So with that, I wish you all the best and good luck, and I end up my session with Assalamualaikum and peace be upon you. Thank you.